In this lesson, we will examine a type of notation that allows us to express familiar concepts in a different way. Now, in the past, we have examined expressions like the one shown here. Notice that the value of this expression depends on the value of x. So, for example, if we want to find the value of this expression when x equals 3, we take the expression and plug in 3 for x. When we evaluate this, we get 16. So this expression has a value of 16 when x equals 3. We can express the same concept here using function notation. Now please note that this notation here does not mean f times x. It is just the notation we use to define a function. Now with this notation, we are saying that 2x squared plus x minus 5 is a function, and its value depends on the value of x. This is the same as saying 2x squared plus x minus 5 is an expression whose value depends on the value of x. Now with this new notation, we say f of x is equal to 2x squared plus x minus 5. You can think of this as taking the expression 2x squared plus x minus 5 and assigning it the name f. So if we want to find the value of 2x squared plus x minus 5 when x equals 3, we use this notation. We read this as follows. If f of x equals 2x squared plus x minus 5, then f of 3 equals what? So we'll take our function here, and to find the value of f of 3, we'll plug 3 in for x. At this point, when we simplify, we get 16. So if f of x equals 2x squared plus x minus 5, then f of 3 is equal to 16. Notice that we are simply using different notation here to express the same concepts that are expressed here. Okay, now here's an example of a word problem that we can rewrite using function notation. The cost C of a taxi ride is given by C equals 1.5 m plus 2.5, where m is the number of miles driven. Notice that the cost of the ride depends on m, the number of miles driven. So if we want to find the cost of a 4-mile trip, we must recognize that m equals 4, and we want to find the value of C when m equals 4. To determine this cost, we'll replace m with 4 to get the following. When we simplify this, we get 8.5. So the total cost of a 4-mile trip is $8.50. Now another way to express this information is to say that we have a function c that helps us determine the cost of a taxi ride. So here, c of x is equal to 1.5x plus 2.5, where x is the number of miles driven. If we want to find the cost of a 4-mile trip, then we want to find the value of c of 4. In other words, we want to find the value of the function c when x equals 4. To find the value of c of 4, we will replace x with 4 and evaluate this to get $8.50. So once again, we are simply using different notation to express the same idea. So if we are told that f of x is equal to x cubed plus 5x minus 1, then we can evaluate f of 2 by plugging 2 into the right-hand side. When we simplify this, we get 17. So our function f evaluates to be 17 when x equals 2. In other words, f of 2 equals 17. In this example, if we want to evaluate f of -1, then we plug -1 into our function to see that f of -1 equals -7. In this example, we want to evaluate f of k. To do so, we'll plug k into our function. At this point, we cannot simplify the right-hand side any further, so we can say that f of k is equal to k cubed plus 5k minus 1. Finally, in this example, we want to evaluate f of 2m. We will do this by plugging 2m into our function. When we simplify the right-hand side here, we see that f of 2m is equal to 8m cubed plus 10m minus 1. Okay, let's summarize. The important takeaway here is that function notation is really just a different way to express the concept of evaluating expressions.